Alright, number 6. We want to use Scartay's rules of signs to determine the possible number of positive and negative real zeros. And it says be sure to include all possibilities, so be careful with that. The answer says number of positive, and then it says number of negative. Alright, so what you need to do to figure this out is just count the number of times the sign changes. So starting with this first term, it is positive, and then it changes going to the next sign to negative, so that's 1. And then it changes back positive, so that's 2. Changes back negative, so the sign changed 3 times. So starting here, we go 1, 2, 3. So we're going to put 3 here. It says that you count the number of sign changes, and then that number decreased by an even integer. So we start out with 3, and then we subtract an even integer, which would be 2, and that would give us 1. So possibilities are 3 or 1. I wouldn't subtract 2 here, because if I subtract 2 again, I would get a negative number, and I can't have a negative number of possible real zeros. So you start out with whatever number you have, and then you reduce it by an even integer, and you keep doing that until you get the lowest possible number, which would be 0. So I can't go past 0. So 3 and 1 are possible for the positive. When we do the negative, we are going to be looking at the negative of this function, or rather negative x. So we're going to plug in the negative x. So we have 2 negative x to the third minus negative x squared plus 2 negative x, and then minus 1. Alright, so first we're going to simplify this. So negative raised to an odd power is still going to be negative. So this will become negative 2x cubed. Negative squared will be positive, and that will make it negative again. So we just have negative x squared. This will be a negative 2x, and then minus 1. Alright, so here's our new function when we plug in a negative x, and the sign is negative. It's still negative, still negative, still negative. So there were no sign changes here. It was negative the whole time. So possible positives are 3 or 1, and then possible negatives, there are none. Alright, now part 2. It says use synthetic division to identify integer bounds of real zeros. We're going to find the least upper bound and the greatest lower bound. Okay, so with this theorem, we are going to just kind of pick a number. Now notice, if we did the rational root 0 theorem, we would have 1 over 2, and you could see, so far off the screen. Let me come down a little bit. If we did rational root theorem, the back number is 1, the front number is 2, so we would be looking at 1 over 2 or 1. Okay, so our list of numbers would be 1, positive or negative, 1 or 1/2. Alright, so I could use 2. So I use this to kind of get me an idea. And when we do synthetic division, what we're looking for is all positives. If I see a negative, then this is not going to work. Alright, so I'm going to use 2 to see if this is going to be my least upper bound. 2, negative 1, 2, negative 1. That would be my numbers. Pulling out my coefficients. Alright, bring the first number straight down. 2 times 2 is 4. Add these, we get 3. Subtract them actually. 2 times 3 is 6. Add these, we get 8. 2 times 8 is 16. Add these, we get subtract them, we get 15. Alright, notice how all of these are positive. This is a sign indicating that 2 is an upper bound. Okay, it may not be the least, but it is definitely an upper bound. So let's try 1. We know 1 is a part of the equation, but let's see if 1 is actually an upper bound, or the least upper bound. Alright, so I'm going to do the same thing with 1, hoping to get all positive. Now 0 could be counted either negative or positive, so understand that as well. So I'm going to try 1 here. 1 times 2 is 2. Add these, we get 1. 1 times 1 is 1. Add these, we get 3. 1 times 3 is 3. Add these, we get 2. Okay, so actually 1 works, and 1 is the smallest upper bound. So this tells us that when we do synthetic division, we do not have to go any higher than 1. Okay, that's the highest we're going to go. So positive 1 is going to be our least upper bound. Okay. And then we're going to go to lower bounds. Alright, so lower bounds, we're going to still be doing synthetic division. However, this time we have to use a negative number, and we want the signs to alternate from negative, positive, negative, positive. Alright, and here's what I meant when I said negative 1 could count as negative or positive, and that could be either case. So I'm going to start with negative 1 because I know from my list that it should work, or there should be nothing bigger than negative 1. So plug in negative 1. Negative 1 times positive 2 gives us a negative 2. Add these, we get negative 3. So we got positive, then negative. Negative 1 times positive 3 gives me a positive 3. Sorry, negative 1 times a negative gives me a positive. Add these, we get positive 5. And then negative 1 times 5 gives me negative 5. Add these, we get negative 6. Alright, so notice how the sign changes. It's positive, it's negative, positive, negative. That gives us an indication that this is a lower bound, and so the greatest lower bound actually. So positive 1 and negative 1. Now it worked out nice this time because we had such a small list, but sometimes you'll have a much bigger list and you want to know, well, do I need to try all of these or do I not? And so the rules say upper bound, it has to all be positive. Lower bound, you want them to alternate signs positive and negative. And if you got 0, that is okay. 0 could be counted as positive or negative. Okay. Alright, so now step 3. It says using the answers in the previous steps, polynomial division and quadratic formula, we're going to find all the possible zeros. Alright, so all we have is 4 numbers to try. 1, positive and negative, and 1/2. Alright, so let's actually do that. And this won't take very long doing it by hand, so let's just do that. So we're going to try positive 1. Two x cubed. Turn this light off, it's a glare. 2x cubed. And then we need some light though. And we'll just move it. Move it right there. Alright. I don't want 2x cubed. I actually want just the number 2. So my coefficient 2, and then a negative 1, and then a positive 2, and a negative 1. See if 1 works. 1 times 2 is 2. Subtract, we get 1, 1, 3, and 3 will not give us 0. Okay, so positive 1 does not work. Alright, so let's try negative 1. Negative 1 will give us negative 2, give us a negative 3. That will give us a positive, I'm trying to add already. This will give us a positive 3, and that will give us 5, and that will not be 0 when I multiply that. Alright, so neither 1 nor 2 works. So let's see if we can factor this by grouping since it's a trinomial, and then we'll be able to find our zeros that way. I wanted to see if it worked with synthetic, but that's what you would have to do to try and see if they worked. Alright, 2x cubed minus x squared. We're going to group the first two together, and then we have 2x minus 1. Group those two together. These two we can factor out in x squared, and what we have left is 2x minus 1. And notice this is already 2x minus 1, so we're just going to say we're going to factor out a 1. Okay. You always want to factor something out. That way you have your two terms remaining. Alright, together they have in common 2x minus 1. And then what we have left is x squared plus 1. Alright, setting each of these equal to 0, we would get 2x equals 1 divided by 2, so we get x equals a half. That was one of those numbers in that possible list. And then if I set this equal to 0, we have x squared equals negative 1. And then you take the square root. Well, we can't take the square root of a negative, so we would get x equals positive or negative imaginary 1. Because we're going to have square root of negative 1, that would become an I, and square root of 1 is 1. So we have 1 times I, which is just I. So positive or negative I and positive 1/2. These will be our solutions. So 1/2, and then we have I and negative I.